Here we have on the left an Exeltech XP1100 power inverter. These are a Pure Sine inverter. I'm not paid by Exeltech or anything, but this is the brand I started buying when I got into this, and I've just stuck with them because I've been very happy with these inverters. That one's an 1100 watt, so it's somewhere on the order of about 8 amps of AC power on the output. Not bad. You can run a lot of appliances off of that. You obviously can't run an electric clothes dryer or an electric range or anything like that off of there, but you're talking TVs and Ethernet routers and alarm clocks, lighting. If you have LED lighting, you can support a lot of lighting off of an inverter like that. So to the right of it is another Exeltech. That's a 600 watt inverter. That one's a 48 volt DC system. So the plan here is to add another 4 batteries to this system in series and go to a 48 volt total system, and then have 24 volt inverters connected to the system as well, so you can use either half of the bank or the total bank altogether. So anyhow, we'll show you some waveforms on the oscilloscope of this inverter versus the utility grid power. Here's the signal from the Pure Sine Wave inverter. It looks nice and clean like it's supposed to. The peaks are nice and clean, the troughs are nice and clean. That's a good sine wave. Looks very good. Now we'll switch it to AC grid power, just a residential service, but we'll switch, and there it is. You can see a little bit, some distortion in that waveform, a little bit of distortion on the peaks and troughs. Almost looks like some mild clipping or some sort of saturation. And there's also a little bit of distortion in the rise and fall of that waveform as well. So back to inverter. Nice and clean, very good. Back to utility. And a little bit of distortion there. I'm not exactly sure what it's from, but it is there. And back to solar, please, inverter. And there you have it. And this was all on this Tektronix Oscilloscope here. Older 2225. Still a good scope.